Hi, my name is Lukas Sobolevas, and today I'll be showing you the project I created for my PCG assignment, where our theme was uh, a theme of monsters, and I chose to do a worm monster within a desert environment, which mostly is inspired by the movie Tremors, just because of the ease of movement the worm would have through a environment like a desert sand, as sand is quite loose and therefore easier to move around for a worm monster. This is my idea, and I'll walk you through the technical side of my PCG toolset, as well as show you how to use it and how it could be used. Let's get into it. To start off with, I'll be showing you how I created the worm monster within the Houdini program, how I introduced the PCG features within the worm monster, and show you how they work. Let's get into it. To start off with, the worm head is created by using a sphere, which then is randomized, or the vertices are randomized a little bit just to give a little bit of noise to the head so it doesn't look smooth, as you wouldn't expect a monster head to be completely smooth. We then use a tube, which we also add some noise to make it less smooth again. We then put it into a boolean, which the tube will take away from the sphere, which makes a mouth inside the sphere. We then copy the same tube that we used to take away from the sphere to make a mouth, and we just use it to have some points to then be able to put teeth on to those points, and then we merge it together with the head. We use a circle just to close off the mouth to be able to put in a fake mouth texture within the throat of the monster, just so it's not possible to see inside of the monster. And so for our body of the monster, we use a sphere to put it as a tail, and then a tube to act as a body. What we do then is add some noise to our tube just to make it look a little bit less random, or a little bit less smooth, and to give some geometry to our monster. We then remesh our tube. This is to make the tube less grid-like within the mesh, which then allows us to put our scales on in a more interesting and less predictive way. To make our scales, we use a circle, which we then reverse just so it points up instead of down, and our textures show properly. We divide our circle into 4 pieces, and then use a poly extrude node to inset the edges into the shape, which then allows us to later be able to move the shape a little better than if we didn't inset the node or the scale. We then use a subdivide node, which divides the circle even more and gives us a lot more options on how the shape can be moved and manipulated within different nodes later. Then we edit how our shape looks by these nodes right here. We use a Unreal material to be able to put a material that we create within Unreal Engine, just so we could make our monster look a little bit more better looking. And then we use the bend node to bend or scale a little bit to just make it a little bit more interesting than when it's flat. And then we copy to the points of our body tube that we remeshed, and it creates this nice looking scale effect to our body of our monster. We then use a poly extrude node to give our scales some depth, which in turn makes our worm look nicer in the end product. So we got our worm monster right here that we created in Houdini. These are some of the parameters we can change to be able to procedurally change the monster within Unreal Engine. As you can see, we can edit these teeth column and teeth row numbers to be able to put a varied amount of teeth in our columns as well as rows, and this allows us to customize our monster within Unreal Engine however we want. As you can see, we can also edit the body scale size. The lower the number means the more scales our worm monster will have, and then the higher the number, the bigger the scales will be, and the less scales the monster will have. By editing the body amplitude, we make the worm monster's body more rugged and less straight, where the body roughness makes it look a little bit less smooth, as you can see within the Unreal Engine example, where putting the roughness down to 0 makes the worm look smoother, while putting the roughness up a little bit makes the body less smooth. By using Unreal Engine and its features, I was able to create different PCG tools that allow me to model a simple but good looking desert town, and I'm about to show you what some of these tools do and how to use them. The first tool that I've created is the ability to basically draw a area within a spline. So let's say I draw some grass right here, and then it starts populating the area with houses, but that's only within the area of the grass that's drawn in. Then we can start adding some roads, which we do by drawing over the houses so the buildings start to disappear. This allows us to create a network of roads or just pathways within a town. And then let's say we want to add some dirt for a farm later. We can start adding it in a corner right here. And once we've done with our town layout, if we zoom in a little bit, we can see the grass area not only is populated with the buildings, but it has some foliage, it has some wells around, and this is basically what the tool is made to do. Just to mention, the tool only works within the blueprint class, or within the spline. So let's say if we move outside the spline right here, if we draw anything like grass, nothing will spawn or be populated within the grass area. So just to keep in mind when using the tool. The next tool I want to showcase is the wall tool that you can use to put a wall around your town that you created. So you put in the blueprint class, which is basically the same as the previously showcased tool, but this basically follows a spline, and the bigger the spline you make, the longer the wall will be. And if we want to make the wall follow our town outline, we can simply just hold Alt and then create this wall by ourselves right here. We make an entrance, and then we find our little block right here. We can either make an entrance like this, or we can join the walls together just like so, and then we drag our little white block over the spline, and it makes a gap within the wall. This can then be made bigger, so the gap is bigger for our application. And this can also be copied and duplicated along our spline, and so we can make as many gaps as we want within our wall, with making different entrances in different parts of our town, just to make a nicer or somewhat more realistic wall right here. Another tool I wanted to show you was the fence tool. It basically allows you to make a fence just like the wall. Works exactly the same. The only thing is there's foliage growing around the placed fences, but it also looks a bit nicer within a town area. So if we wanted to make a little farm pen for our animals, or just a fence to follow our farm to close it off from like the public, we can do that easily by just editing or adding more splines or more points to our splines, and this allows us to create a nice fence quickly and without much trouble. Also allows us to make a gap in the fence like our wall, and once we actually play the game or play our scene, these cubes will disappear, and we will only see the gaps within the fences. And so for the last tool I wanted to show was the farm generation, a PCG farm. So basically you put down a blueprint class, and then you're able to scale your farm as big as you want. So let's say we want to populate this dirty area with our farm, and so we can do that by just expanding our farm on the by using the spline points right here, and we can just easily create a farm like that without much trouble, and within a minute or two we could even make it look a lot better by just adding more spline points to make it more customizable to our town area, wherever we want to place down this farm. And there you go. The PCG landscape tool works by getting the spline data within the spline that's put down as I showed you. It then puts some points down into the spline or within the spline boundaries. A landscape is put in to then be able to project these points onto the landscape, and then those points or these nodes will check every single point and what their what the landscape material beneath them is. So let's say if the landscape material is rock, it will not spawn a house or a building on top of the rock material. Same as with sand and dirt. And then because we do not mention grass in these point filters, this means the building will spawn onto the grass using the static mesh spawner, which I set a few different buildings just to get a varied town instead of having the same asset for every building. And I think it makes it look more aesthetically pleasing. So we get a spline data, or we get the spline data, and then we put some points on top of those splines, or on top of that spline. We get a difference, just so if a cube actor is on top of a point, that means a mesh will not spawn on that point the cube is covering. We then project the fence onto the landscape, and then spawn the fence using the static mesh spawner node. And this, all distance node does is just affect how far the grass spawns, how far away the grass spawns or can spawn from the middle of the fence. Difference node also, or this node will make sure that if a cube actor is on top of a point, then the foliage or the mesh will not spawn on that point. Projection makes sure that the grass is on top of the landscape, and the static mesh spawner just spawns some grass and some bushes around the fence just to make it look nicer. The wall generation works completely the same as the fence. The only thing it's missing is all the foliage growing around it, and every single node is basically the same. And lastly, we have our farm, the PCG tool. All it does is quite simple. It creates a point grid, and then we use the spline sampler as well. We intersect all of that information, which creates us these lines we can use to then firstly project onto the landscape, and then start spawning different meshes, such as soil, which is basically this land right here, and then also allows us to put some crops on top of it too, like these flowers right here. And finally, for the end of this video, I just wanted to show you what my end scene looks like using all the PCG tools that I've created, and hope you enjoy it.